Hello everyone, this is the tutorial class of the second assignment for the second and third law of thermodynamics. And okay, we can see the first question. The first question is that first part is to ask us to prove this equation. For the proof process, we can have this one. This is the first law to calculate the delta W in a process. And this is a second process. And the second question is to calculation the Q. This is a second law in the equation form. So we have this one. So compile of this one, and then we have this one. And then we can write delta S as this one, because the delta S equals to dq minus t. dq divided t, so we have this one. So we have this delta S equals to this one. This is a proof process. And because for the ideal gas, we have the Cp minus Cv equals to R. So we can write this delta S equals to this. And also, we can get the final result for delta S equals to this one after calculation. And for the second question, this is a calculation entropy in a process. And also, similarly with the first question, we can have this ds equals to this one. The first part is for it is for constant pressure process, and the second part is for a thermal process. And so we have the ds equals to this by do the integration of the equation in the both sides. So we have the delta S equals to this one. Then for the third question, the third question is a proof question. We have the alpha. This is a expansion coefficient, and the compression coefficient k. So we have this one, and to prove the Cp minus Cv equals to this, and first we can simplify the right side of this equation. Then we have this one. By replace the alpha and k, use this and this in this equation. So we have this one. After we have this one, this is a definition of the Cp, and this is because the u is a state function, we can write the u as a function of t and v. So we have the u equals to this one. This is a differential form of u in t and v. After we have this, we divide the differential t in this side and this side. So we have this one. Their dt is divided by dt, so equals to 1. So we have this one. And then we have the definition of the Cv. So we have Cp and Cv, so Cp minus Cv equals to this. And then we use this equation to replace the differential u over differential t there. So finally we have this one. After we have this one, we use this equation. This equation is an equation come from the first law and the second law. And later I will give a proof process for this equation. So after we have this equation, we can use this part to replace the du in this one, so we have this one. Then we have in this process we have used the Maxwell relation, the differential s over differential p equals to differential v over differential t. This is a Maxwell relation equation. So after we get this, we finally have Cp minus Cv equals to this one. So finally we have proved this equation. And then for the first question, this is a calculation question. For this question, we have to calculate the data in the three different processes. First one is a no heat exchange process. So we have the surrounding equals to 0 because in this process there is no heat exchange between the surrounding and the system. After we have Q equals to 0, so we have ds equals to 0. Because this process is reversible, so we have dq equals to delta ds equals to delta q minus over t. So we have delta s equals to 0. So we have delta s total equals to delta s plus the delta s of our surroundings equals to 0. Because delta s total is 0, so this process is not spontaneous. And for the B process, this is a expansion process at the external pressure equals to 0. This means the external surrounding is a vacuum surrounding. This question is much similar with the 11th questions in the later. Because the surrounding is a vacuum, so we have dt equals to 0. After dt is equals to 0, so we have du equals to 0. We have this one. So we have delta s equals to minus w, so equals to this one. This is minus w over t. So we have the delta s there, and the delta s total equals to this one. Because the surrounding is a vacuum surrounding, so delta s surrounding equals to 0. So we have delta s total equals to this. And for the third process, this is an asymptotic process. Also, this is a reversible process. So we have similarly we have du equals to 0, then w equals to minus q, also equals to this one. So the dq equals to this one. Because this is a reversible process, so the delta s of the surrounding equals to this one. This means the Q of the surrounding equals to the Q of the system. So we have the delta S total equals to 0. Also, then for the fifth question, this question is to calculation. This is a calculation question in a chemical reaction equation. The first question to calculate the delta G in this reaction. This reaction is a transform process of the graphite to the diamond. So first we calculate the delta H of this reaction. Delta H equals to the entropy of the combustion of the graphite minus the entropy of the combustion of a diamond. For this one, you have to pay attention to the difference of the entropy of the formation and the entropy of the combustion. If in the question we have knowing the entropy of the formation of a diamond and graphite, the delta H of this reaction should be equals to the delta H of the formation of a diamond minus the delta H of the formation of a graphite. This is just the opposite for this equation. So we have the delta H there, and also for delta S equals to the S of the product minus S of the reagent. So we have the delta S equals to this, and the delta G equals to this one. So we have the delta G. Finally, we have delta G. For the second small question, because we have known in the delta G equals to this, and this one is bigger than 0, so this means this transition process is not spontaneous because the delta G is bigger than 0. For the third question, it asks us to force the reaction toward the unstable form by increased pressure. This means can we transform the graphite to diamond just by increase the reaction pressure? The answer should be yes. So this is a calculation process. First, we have to know the delta G of this reaction's relation to the pressure for this reaction. So we have this one. For this equation's proof process is there. There is a proof process for this equation. And then after this one, we get the relation between the delta G and the pressure of this reaction. So we have the delta G equals to this one. This is to do the integration for this equation. So we have this one. And then we have delta T equals to this one. This is standard delta G. Also the calculation result in the first small question. This delta G is at the pressure. This pressure is transition pressure when the diamond, when the graphite can transform to the diamond. So we have this one. Because we want this reaction to happen, so this delta G have to be less than 0. So we have this one. Then we have this one. After calculation, we have the pressure is bigger than this one. It means when pressure is over than this value, the graphite can be transformed to the diamond. Okay, let's see the third question. The third question is it's just like a mixed press of two different gases. But in this question, this is two iron cube. We put two iron cube together, so we have the temperature of the two cube, and also the of the tube and the temperature of the water, and this is the heat capacity of the water. So we have this one in this process, the heat get by the water equals to the heat lost by the cube. So we have this one. This is equation, and then we have this one, and then finally in the last we calculate the entropy of the iron cube, and the initial temperature is equal to this, and the entropy of the water and the initial process and the initial temperature equals to this, and the entropy of the cube and the final temperature equals to this, entropy of the water and the final temperature equals to this. So in the total process, we have the change in entropy of the ion cube equals to this, and the entropy of the water equals to this. So the net change in this total process in entropy equals to the change of the water plus the change of the ion cube. So the total change of the entropy in this process equals to this. Because the delta S in this process is bigger than 0, so this process is not reversible. Okay, for the second question, this question is very simple. Because in this process, it is a constant pressure and temperature. So the heat in this process equals to this one. This is more n multiplied by the delta H. The delta H, this is a vapor entropy of this evaporation process of the water. Of this liquid. So we have delta S equals to Q minus T equals to this. Then this is a eighth question. This question also is a proof question. And in this question, we have this one to write the total differential du of this one. So just like previously, we have this du equals to this one. By use the differential form of the v and the differential form of the t. Also, we have this one. I have given the process of this one, and then we have this one. Just use du there to replace the du there. So we have this one. Then we use Maxwell relation. This is the proof process of the du equals to this one. This equation. This is four equations in a Maxwell relation. So we have this one. After use the Maxwell relation, we have this one. And for the third small questions, we have to use a perfect gas equation, PV equals to nRT. So we have this one. Finally, we have this one equals to 0. Then for the next question, this is a calculation questions in biology process. This is about the structural transition in enzyme. These enzymes structural transitions Earth and this temperature. But we have to calculate the entropy of the unfolding of this enzyme and this temperature. So from the hints in the question, we have to divide this process into three different processes. The first is a constant pressure process, just increase the temperature of this kind of enzyme. And the second process is a thermal process in the transition temperature to do the folding process. And the third small process is also a constant pressure process, and also is a decreased temperature process to decrease the temperature from the transition temperature to the room temperature. So from the three different small processes we have, this is a entropy change in the first process, and also for the third small process, and also this is entropy change in the second small process. This is a unfolding process of this enzyme. So we have the total. We have the total delta S in this process equals to this one. And then for the 10th small question, this question also is a simple calculation questions. In this questions, it gives us a situation. In this situation, the Cp is not independent of the temperature. It means the Cp will change as the temperature changes. So we have first we have delta S equals to this. This is these equations you can remember this because for many questions you have to use these equations in this in the process like the process in the question. This part is a thermal part, and this part is a constant pressure part. So we have this one. After replace the Cp in this equation, so the remaining things is just the mathematical calculation process. So finally we have the delta S in this process equals to this. Okay, for 11th questions, this is also a calculation for a given initial state and final state for a perfect gas in a different process. This question is just like the questions, the first questions. For those three different process, we have for the first one. Because in this questions, this is temperature is constant, so the delta U equals to 0 for 1, 2, 3 small question. After delta U equals to 0, because this is a reversible process, so delta H equals to 0, Q equals to minus W, and so W equals to this, and Q equals to this, so delta S equals to this. In the second process, second small question, delta U equals to 0, delta H equals to 0, Q equals to 0, W equals to 0. This is because this is a vacuum expansion process, so the W equals to 0, so Q equals to 0, because Q equals to delta U minus W. And because the S, U is the state function, so it means the change for S and U in a process is just related to the initial state and the final state of this process. Because for the three different process, the initial state and the final state of this kind of gas is same. So the delta S should be also the same. So delta S equals to this one. Just same with the first small question. Also for the third small question, delta S equals to this one. For W, because this is a expansion process, when the external pressure is constant, so we can just simply have the W equals to minus P dV. dV equals to final V minus initial V, so equals to this one. This is some hints. Okay, for the 12th question. This question is not for just for PV equals to nRT. This is PVN. The PV power of N equals to this one. So similarly, we have in this constant volume process, similarly we have the entropy delta S change equals to this one. And for another process, the PV power of N equals to this one. We have the delta S equals to this one. So because the entropy change in these two different processes is the same, so we have this one equals to 1. So after a simple calculation, we have n equals to this one. For the next question, this question is also a calculation question. This told us this is the initial state, and the final state is this one. So that is equal in the reversible process, and for an irreversible process. And similar with previously, we can divide this process into a two-step reversible process. The first is the isothermal process. This part is indicated there. This is there. This is a isothermal process, and another process is constant pressure process. In this process, the temperature is changed. This process is indicated in this part there. This is a constant pressure process. So we have delta is equals to this one there. And because the S is a state function, as I mentioned in the previously, so the delta S should be equal to the reversible process. Even this process is not reversible process at a constant external pressure. Then for the first question, the 13th question is about a Carnot cycle calculation. It asks us how many Earths can be reproduced in one day by this small refrigerator. First, we have to use this equation. This equation is Carnot cycle's efficiency equation. This is efficiency of this Carnot cycle, also known. And for this one, we have this one. The W should be the power of this motor. So we have this one. And after we have this one, we can do this calculation. This is Q over T equals to this one. And this then multiplied by T. So I have this one. And for the next question, this is also a the perfect Carnot cycles calculation question. In the first point, from this picture, we have this point 1, we have this one, V1, P1, and from this equation we have T1. And from point 1 to point 2, because this is a isothermal process, so in the point 2 we have the temperature equals to this. And then for the point 4, the point 4 is no heat exchange process from point 1 to point 4. This means this equation is there in this process, so we have the pressure temperature in this one. And also for the point 3, because from the point 4 to point 3, this is a constant pressure process, so the pressure is the same, so we have the temperature equals to this. So this is 1, 2, 3, 4. This is a calculation of the test in the 1, 2, 3, 4 process. Just like the previous question. So for the totally delta S in this cycle is equals to 0 because from 1, 2, 3, 4, 2 to 1, it returns to the origin state, so delta S equals to 0. For the sixth process, I think this question is very difficult. Because in these questions, it assumes that the hot source is infinite and the cold sink is not infinite. It means after we extract the heat from the hot source to the cold sink, in this process, the heat from the hot source will transform to the cold sink. At the same time, we can also get some work from this process. Because the cold sink is not infinity, so in the finally, the temperature of the cold sink will increase to the temperature of the hot source. The temperature of the hot source and the cold sink will reach to the equation. So first we have the Carnot cycle efficiency like this, and for this equation we do the differentiation for this one and this one. So after doing differentiation for this one, we have dW equals to dq multiplied by this one, and then we do the differentiation of this one. After do the differentiation of this one, we have the dqh over dqc equals to this one. This is just this equation. And also we have a dq equals to c dt. This is a definition of the heat capacity of a material. So we have this one. After we use this one to replace the dq, dqc there. So we have this one equals to this one. And after we get this one, we have dW equals to this one. Because in the question, it asks us the maximum work we can do. So we do the integration for the dW, we have a W. We do integration for this part, finally we have this one. So finally we have a W equals to this. This is the maximum work in this process we can get. And for the 17th question, this is just the Helmholtz energy question. For the first question, because the volume change in this reaction is 0, because the oxygen's volume equals to the carbon dioxide volume, so we have this one, delta H equals delta U. Because delta U equals to delta H minus delta PV, so delta V equals to 0, so we have delta H equals to delta U. So therefore we have this one, energy available as heat is equals to this. And this temperature we have the delta A equals to delta U minus T delta S. This is a definition of the Helmholtz energy, so I have this one. And the definition of Helmholtz energy, means the maximum work in a process we can get. So when we get delta A, we know the maximum work we can produce in this process is this one. Okay. The next question. This is a question to put two copper subjects together with a different initial temperature, but they have the same mass of 500 grams. So, as this process is an insulation process between the copper and the environment, so the Q equals to 0. This means the Q. This is a heat lost by the high temperatures copper, and this is a heat gained by the lower temperature copper. So their plus equals to 0. So we can get the final temperature is this one. After have a final temperature is equal to, we have this one. This is for the low temperatures copper. And this is for the high temperatures copper. So we have this one. And for the next question, this is a proof question. I think this question is just a mathematical question. This is a little difficult, but first we from this Maxwell relation, this one, and we get this one. This is because we use PV equals to nRT, so we have a P equals to nRT over V. We have this one. For this one, because the V is constant, so for this one we do the differentiation of T, so finally we have this one. After we have this one, we have this. Why we have this? Because in a constant temperature, this is a dV, this is a differential V. So actually they all equals to ds, so we have this one. This is because we use this one to replace this one, just equals to this one, replace this one, so we have this one. After we have ds equals to this one, we do the integration for both sides of this equation. So ds, we integrate ds, it will equal to s. We integrate this one, it will equal to this one. So we have s equals to this one. Finally, we prove the question. So for another question, I think this is very, very difficult. How to understand the means of this question? It means we have the liquid water and the ice. The ice can be regarded as a solid water. So we have the liquid water and the solid water at the same temperature, the -5 degree. In this temperature, we have to calculate the entropy difference for the liquid water and the solid water at this temperature. Also for the liquid water and the vapor of the water at this temperature. For those two forms of the water, liquid and vapor, we have to calculate the delta S for the liquid water and the vapor. So how to calculate this question? First, we have to divide this process. I mean, from the liquid water to solid water at this temperature to three different small processes. The first process is a temperature change process, but the water still keep the liquid state, so the temperature from -5 to 0, and the second process is a state transform process. It means the water changed from the liquid state to the solid state. This process can regarded as a reversible process because we have the entropy change for water from the liquid to the solid at 0 temperature. There, we have there. This is a entropy change for the water from liquid to solid at 0 degree. And for third small question, this is also a temperature change process. The water state is not changed, it keeps solid. So we have this one, and this one. And then finally we have the delta S transform equals to this one, plus this one, plus this one. So the remaining things is just the calculation. For the first delta SL equals to this, delta SS equals to this. So we have this one, then we have this one. And because the delta S in this process, I have emphasized for this process, this is we have knowing the delta H in this process. It's just this. So we have the delta S equals to this one because this is a reversible process. And then we have this one. This is delta S. This is delta S for the system. Also can be regarded as just for water. And then this is a calculation for the delta S of the surrounding. For surrounding, firstly we have to calculate the delta H in the total process for the surrounding. So we have the delta S equals to the first process, second process, third process. So we have this one, Cp, temperature, Cp, multiplied by delta T. So we have this one. Then surrounding equals to this one. After we get the surrounding, we can get the total delta S in this process equals to the delta S surrounding minus delta S of the system. So we have this one. The delta S is bigger than 0. It means this process is spontaneous. Which process is spontaneous? This process. Revert from the liquid to solid. So it means in this process, the water can freeze to ice at -5 degrees. And for the second small question, it asks us the difference of the S, also delta S. In other words, delta S between the liquid water and the vapor at this temperature. The calculation process is just like the same with A. We can also regard as this process into 3 different small processes. The first process is the water from the 95 degree to the 100 degree, and then at 100 degree, the water changed from the liquid to gas, this one. And then the third process is the temperature decrease process. The temperature decrease from 100 to 95 degree. So we have this one. And then we have delta S total equals to this one. Since in this process delta S minus 0, it means this process is not spontaneous. Which process? Because in the beginning, the process we said is from the liquid water transformed to vapor water at 95 degrees. This process is not spontaneous. In other words, this means the opposite process is spontaneous. So the opposite process is water transform from vapor to liquid. So this process is spontaneous. Okay. This is all the question in assignment for second and third law of thermodynamics. If you have further questions, you can just contact with me by the email. This is my email. So so that's all. Bye bye. Good day. Bye bye.